Thanks a lot, Michael, for the introduction, and thank you, Regina, for the invitation. It's a real honor to speak to you today about our work with conversational AI. Perhaps a couple of more words about why this and what does it have to do with our work at Swisscom. Personally, I have worked a lot in research, and I am very passionate about research. But as I have progressed in my technological profession, I also developed a very strong passion for meaning. And this presentation is about bringing these two together, because technology, I found, is very often about excitement and curiosity and trying things out, which is great. But at some point, we also have to think about the meaning of those things. And Swisscom conversational AI, it's really clear from the mission of Swisscom and the kind of the goals that we set for ourselves. As a leading ICT company, we shape the future and inspire our customers with a cutting-edge network, high-performance offering, and excellent service. And the focus here is on excellent service, while, of course, also keeping reasonable costs. And for this, we, of course, like any other company, explore options of recent conversational technology. And to dive into customer communication, I want to tell you a little anecdote from my personal experience working for our enterprise customers division. I had the great chance to visit a banking customer of ours right here in Germany and to explore their customer service. So I was really sitting next to a customer service agent for about 1 hour. I had a headset myself, but without the option of speaking to the customers, of course. And just, I was just observing her at work and listening to the customer calls and to her behavior in those calls. And I was really amazed at her endurance and at her empathy and at how she was able to say the same things all over again, like, oh, my credit card is late and it's not coming, it will come, don't worry, you can check the status there, like 10 times in a row. And still, being nice and pleasant and engaging. And she did this for the entire hour, and I was just sitting there. And at the end, I felt really exhausted. Like, I just felt like I'm going to walk out of there and drop dead. And for her, it was, lunchtime. Maybe she had a break, maybe she didn't. She had to continue doing this for the whole afternoon. And I realized after this experience, how important and how undervalued call center agents and customer support professionals are. Considering the fact that they are the image of a company and they are really the first line in the customer interaction, and they have a huge influence on the perception of customers towards a company. And what I wanted to transmit with this story is that communication is very difficult. It requires a lot of empathy. It requires understanding frustration. It requires being able to read between the lines, to interpret silences, to understand and to express love. And all of these things are already difficult in person or when we have visual contact, even if it's not in person, but it's 1,000 times more difficult when it's only text, like in a chat or in an email. However, artificial intelligence is making a lot of progress in the area of conversations and language in general. There is a very recent benchmark called the General Language Understanding Evaluation, GLUE, the GLUE score. It was introduced last year and already phased out 1 year later because it reached human parity. So this is where it stands today. It consists of 9 tasks which are meant to test a broad range of abilities of a computer model in understanding language. So for example, we have natural language inference, being able to recognize textual entailment, question answering. The model is given a paragraph of text, and it has to answer a question of which the answer is found in that text. Paraphrasing, so rewriting the same sentence in a different way. Sentiment analysis, and acceptability, which means figuring out whether some kind of literary texts are really correct or not. So some of these tasks proved much too easy and are already very well mastered by computer models, which is why about a month ago an improved version, or let's say a harder version of this metric was introduced. It's called the superglue score, and it's now around at 70%. The human baseline that they've measured is about 90%, so there's a lot of room for progress. And they've also changed the tasks. So learning from the experience with the previous 9 tasks, they took only the more difficult ones, and they introduced a couple of additional ones. So now there are 6 tasks in these 4 different areas. So still natural language inference, because this is really difficult. Causal reasoning from a sentence, figuring out what is the cause and what is the effect, also in a question form. Reading comprehension, you might have heard of this if you've taken a standardized English test. You need to read through a text, and you have some options of what is true about that text. And word sense disambiguation, so sentences that contain the same word in different meanings, and the model needs to figure out what the word means in each context. And because of these very encouraging results, it may be very tempting for enterprises such as Swisscom or other companies, and I think there are many companies out there testing bots. It's very tempting to think that they can replace communication with customers, or perhaps at first internally with employees, to replace this with artificial intelligence. But first of all, language understanding, as measured by this glue score or the superglue score, is by far not communication. It's only understanding. There's like a whole different part beyond that in order to really communicate. And second, even models for language understanding have a lot of trouble with certain things such as context. This is an example from the Google Assistant that was valid a couple of months ago when I first composed this presentation. 2 months after that, this was fixed. So they really tried, they made an effort to be able to take into account the previous, 2, 3 utterances. Last night I checked it again. There's nothing like this anymore. So the assistant does not try to engage you after you ask this question anymore. Who are you? It's just a closed form sentence, like I am blah, 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 and I can help you with your, tasks. So for me, this clearly points out that there is still some way to go in producing enterprise or human-grade communication assistants. And so even, let's say, this was fixed, and we could perfectly keep context and understand this, human communication is also about emotion. This is another example from another bot. And what more can I say? There is another good one from PayPal where someone tries to speak to their bot and says, I think I have been the victim of a fraud, and the bot's reply is great. So there's still a lot of room for improvement in interpreting situations and in understanding emotions. And I mean, this is also in research a very unsolved problem. The accuracy of emotion detection in text, it's at around 60%, which is not very much, considering that this is only for the 6 very basic emotions. So there's a lot of improvement to do. But on the other hand, what we have so far can also still be very useful. And the question that I want to answer in the following is, how can we get the most of what out of what is already there? And what I want to propose to you is human-centered data science, which, in my opinion, could provide a way to thoughtfully use the existing technology, even if it's not perfect, to improve companies and people's lives. So let's start with the part that we probably all know, which is data science. What exactly is data science? If we look at a survey from Kaggle, this is from last year, these are the tasks that data scientists spend their time on. There's a lot of data toying around with data, so we have to clean it, we have to gather it, we have to visualize it, and so on. Then there is, of course, a lot of model building and getting things out of this model, insights, communicating these insights. And then we have to do the whole software engineering part and system engineering, putting the model into production and making it available. Looking at it in a more workflow-oriented way. It looks like this. We start by getting a problem from our customers or from our stakeholders, wrestle the data, build the model, iterate, explain, adapt the model, validate it, and give it back to our stakeholders. Now, what about the human-centered bit? How many of you are familiar with the human-centered design methodology? Yay, one person, great. So it's nothing fancy. It's actually quite similar to the Agile methodology, but with a much stronger focus on empathizing and on, well, like the name says, putting humans in the center. So there is this kind of wave shape that this process follows. You start by really empathizing with the intended users of your development, your product, or whatever you're creating. So you really try to not only to ask them what they need or to ask them what they want, but to infer this, because they cannot always tell you what they need. Then once you understand this, you can go to the drawing board and figure out which parts of these needs are really meaningful and which part of these needs a lot of users have in common. Because, of course, it doesn't make sense to build for the needs of 1 or 2 people. Once you have a definition of a meaningful and impactful problem that is touching a lot of people, you start ideating. So it's the phase where any crazy idea is welcome. The goal is really to generate as many ideas as possible. And then you start prototyping, and in a lot of the cases, this has nothing yet to do with programming, really just trying to think about what it could look like, and to the highest extent possible, testing this with users, and then iterate, and start at some point also writing code, of course. And I had the great chance of starting my career as a data scientist in the human-centered design of Swisscom, and this is also why I like this methodology so much, but also because I see a very strong parallel with the workflow of data scientists. So in human-centered design, we empathize with users, we understand their needs. In data science, we spend a reasonable amount of time understanding the problem that our stakeholder, our customer, is trying to solve, which is very similar. In human-centered design, we spend a lot of time defining the problem. In data science, we spend a lot of time analyzing the data in order to figure out what the problem is. Then we spend a lot of time ideating in human-centered design, in data science, we start creating models, different versions of them. And then in both cases, we prototype, we iterate, we adapt until we reached the perfect result. So basically, human-centered data science, in my opinion, is here to help you find a problem worth solving and to make sure that your solution doesn't end up in the data science graveyard, as I think it's been the case in many companies for a lot of projects. And this can happen, of course, regardless of how cool your technology was, how sophisticated your neural architecture was, and how well you optimize your hyperparameters, and so on. So once we come up with the problem, according to this methodology, it should be then relatively easy to find a meaningful solution. And now coming back to artificial intelligence for customer communication. What does applying human-centered data science mean in this context? This is what I want to show you next with the example of our own chatbot. So, as we said, first start with the problem. And this is typically what problems look like when they come from business stakeholders. So as a data scientist, you might be asked, how can we optimize customer support costs? How can we make our customer support be more efficient and ideally cost us nothing? How can we increase conversion rates? How can we get more people to buy our product? But now thinking back to human-centered design, do customers or the intended end users actually care about all this stuff? Probably not. I mean, as a customer, I don't care about the customer support cost of Swisscom or about their conversion rates. I mean, I do care as an employee, but not as a customer. So what would these problems look like in a more human-centered design way look like? Something like this. So the customer, what they care about is that their requests or their problems are solved quickly and accurately. Or in case of conversion rates, what users care about is finding a product that fits their needs in the fastest and most efficient way possible. And if we focus on these rather than the left-hand side, we have a higher chance of being successful. And there are a lot of successful companies that really take this approach of focusing on the customer and have the kind of the understanding that by doing this, the left, in your case, yes, left-hand side will follow just by making customer happy. Okay, so let's say we have the problem. Now, and we know that it's meaningful, it affects a lot of people. Now we can go to the really fun part. We need to know what tools we have at our disposal. So what ideas can we come up with that can solve the problem? And in this case, we're talking about chatbots. So I want to tell you a little bit about how building chatbots work. So on a very high level, we have an anatomy that looks like this with three main components. The first one is natural language understanding. In order for a bot to communicate with a human, the bot needs to understand what the human is saying. Then we have flow management or dialogue management. The bot needs to be able to carry a conversation and to know what should come next after the person's utterance. And then we have natural language generation. So this, what comes next, also needs to be generated in human language. And all of them are not compulsory to create a bot. So there are bots that use only one or two of these. And here are the different categories depending on their internal architecture. So we have, for example, the very, very simple clickbots, where it's not actually a chatbot because you're just getting a bunch of buttons or options, and you can click on your favorite one, and then you go through a flow and get more options at each step until you reach the final goal. And so this is basically an example where you only have the flow management part. The natural language understanding part, you don't need it because you have fixed option. and the natural language generation the same. Then you have goal-driven bots, where you have a lot more freedom. So as a user, you can really write down what you want. Like, I want to book a flight or reserve a restaurant or whatever. And both of these are bots that help you get things done. And then on the other hand side, we have bots that provide you information, or that just chat with you. And these are fundamentally quite different in their architecture, because they're not meant to take any action. They're just there to give you information. So it's all about how they acquire this information. And one way is called a retrieval bot. In this case, the bot has a set of existing data, like question-answer pairs or a knowledge base or whatever. And they don't generate additional information. They just retrieve text or answers from the existing database. And then you have generative bots, which, as the name says, they try to really, even though they also do have built-in information and databases, they generate previously unseen or unlearned answers. And then moving a little bit to the next level down in details, the tools that we can use to build these different types of bots are, for example, for goal-driven bots, we have two very important pieces. We have sentence classification, which, well, classification in itself, it's such a wide area. It can be done in so many ways, but it's the basic piece of the puzzle that we need for bots. We have entity recognition, which is meant to retrieve the information that the bot needs to perform the action that you want it to do, since it's a goal-driven bot. And then moving on to retrieval bots, in this case, what we need is the existing database to be, or the answers to be ranked by their relevance. So this can be done, for example, with an inverted index, which most modern search engines make available to you, like Elasticsearch or Apache Solr. Then you could potentially also use a dual encoder neural network, where you encode, if you have question-answer pairs, you can encode a question with one part of the encoder and the answers with the other part, and then use the embeddings to rank the answers to the current question. And then perhaps as a mixed model between retrieval and generating, you also have things like text-to-SQL, where a neural model tries to take your natural language question and translate it into a SQL query that, applied to an existing table, will give you the right answer. And then moving on to the next category, natural language generation, there things get a lot more complicated, and it's, I think, still a lot harder to come up with reliable results. But these are, at the moment, the two best options. As a baseline, an encoder-decoder architecture, where you, again, try to encode the question, and by decoding, you should get the answer or generate the answer. And the transformer architecture, which is at the basis of all the currently state-of-the-art language models, such as BERT, Elmo, GPT, and all of these seemingly dangerous things. And then for the last part, the flow management, or the dialogue management, we also there have a lot of options in terms of tools. So you can have very simple finite state machine-based flows, which are basically nothing but rules, and very similar to what you have in ClickBots. You can also apply this to goal-oriented bots. You can have really proper neural network-based dialogue management, which is in general done with reinforcement learning, and where through repeated interactions with users or self-interactions, the bot learns the policies for providing answers in certain situations. Again, I would not call this enterprise level yet. And then you can also have dialogue management that is based on knowledge graphs. So basically, especially in, let's say, chatty bots that are only there for having a conversation or entertainment, knowledge graphs can provide a basis for this conversation, especially in coming up with new topics or transitioning from one topic to the next and so on. And of course, you can also have any kind of possible combination between all of these. So as a company, maybe you would start with a very simple inverted index or dual encoder retrieval model. And then maybe you realize, well, actually our customers don't only want to get information from us, but they also want to perform actions. So then you could also have a goal-oriented bot, which you would then have to combine with the retrieval bot. And then there comes the tricky part of the dialogue management and knowing or making the bot understand when it is time for the retrieval part and when it is time for the goal-oriented part. Okay, so now we have a lot of tools, and we have quite a decent idea, I would say, of where we could start with building a bot for our company. So going back to the question, or the problem that we're trying to solve, how can we solve requests quickly and accurately? Well, thinking about user experience again, I would, of course, not want to start with something that is directly customer-facing. So I can definitely think of a way that a first version, or let's say an MVP of a bot, could be first introduced for customer agents. And this is exactly also what we did. And it's basically just taking all the information that you have available, like past solved support tickets or knowledge bases, product manuals, CRM information, and putting them into a search engine and turning this into a very simple retrieval bot. And this was already 3 years ago that we did this. The system has been productive in this time. And it helped in a lot of different areas. So first of all, yeah, it does give useful answers most of the time, otherwise it wouldn't be still there. It does speed up agents. And also what I found really most importantly is that in call center agents where turnover is typically relatively high, it also helps a lot in onboarding new agents much, much faster because they have all of the information at their fingertips. So, but these are only a fraction of the requests that call center agents receive. So if we really want one day that this bot is customer-facing, we need to assess this MVP and ask ourselves a number of questions, such as why would as a customer, why would I use this bot instead of existing other options, like going to the website or going to the customer center where I already perhaps know where to find the information? Or how fast does this bot solve the problem? And what can it do besides giving me information? And I think by going through this list with the retrieval bot MVP, it's relatively clear that it's not really enough for this to be customer facing. And so what we did next is iteration, going back to analyzing the data that we have and figuring out, after we've had a first experience, what are the statistics about the requests that come in in the customer support center. And this looks like a very complicated picture. That's because all of the requests that we receive are classified according to a kind of a crazy system. So we have 1,000 different categories of customer support requests organized in a hierarchy, which may or may not make sense. And what we discovered looking at these data is that only about 100 of those categories actually occur on a regular basis. That's the first learning. And then trying to create a classifier for these requests, which is kind of the first prerequisite in dealing or in creating a bot that can handle these requests. So trying to create a classifier for these, we realized that the existing hierarchy is probably not the most appropriate one. So by using clustering on these customer support request embeddings, we were able to find a lot more appropriate groupings of the requests and come up with completely new categories. And there's still an ongoing discussion about whether the support center would take over this new categorization or not, because obviously it implies a lot of changes. But for the classification part, it's already extremely useful to be able to rework the classes such that the classification is much more accurate than it would be if we were using the original classes. Right, so now that we know which ones are the most frequently occurring requests, we can think about the MVP 2.0, let's say, where in addition to handling retrieval requests, we can also handle transactional requests, such as I want to buy something, or I want to make a subscription, or I want to add this option to my existing subscription, and so on. And in order to train a bot that does this, we need, as I mentioned before, to train for two things. The first is intent or sentence classification. So on a broad level, what exactly does this transaction have to be? Is it buying something? Is it subscribing? Is it upgrading? Is it sending something to the customer? Whatever. And then once we have this figured out, we need to gather the information in order to perform this action. And we do this with entity recognition, where we try from the sentence that the customer wrote to extract the relevant parts of it. So for example, the type of the phone. If I want to buy a phone, I need to know the brand, the color, any other features that the phone should have. If I want to subscribe to a mobile plan, I need to know the type of the plan. I need to know from when the subscription should start, and so on. If I want to buy an extra option for my plan, I need, for example, roaming. I need to know that it is for roaming, and I need to know, in the case of roaming, for which part of the world, and so on. And this is what entity recognition does. It's typically considered a relatively solved problem, but not necessarily in such a broad context as in the case of bots. So I think the key point in goal-driven bots is that even if you may have data from existing conversations, like some companies already use chat systems with real agents chatting with customers, and this is a great starting point, but it doesn't necessarily include the needed training data for building a goal-driven bot, because you need to have sentences that are labeled both with the intent and with the corresponding entities. That's the first hurdle. And then the second one is that as a human, you probably don't speak in this very structured way in which the goal-oriented bot would do, right? So in the end, the real solution is just to have people sit down and start writing variations of each of these sentences, as many as they can think about, and hope that this covers most of your customers' way of speaking. Right, so let's say now we have, again, this MVP 2.0, and here comes again the time to do the assessment. So we have to again ask ourselves the questions. Why should the customer use this new engagement channel, which they're maybe not familiar with, maybe they're scared of, whatever, as opposed to existing ones? What are the other options? Perhaps the company already has a website or an app. These are all usability questions that, regardless of how good your bot are, you cannot get around, and you cannot make your bot successful unless you have an answer to these. The bot can crack jokes but not solve the problem. This is really probably the worst thing ever. You build a very simple retrieval bot, and then, you know, as a technology professional and nerdy joker, which I can totally see myself in, you start thinking of ways to make it cool, and you maybe build in some jokes. But as a customer, that's really not funny when the bot can't do anything but tell jokes. And I have heard from a lot of people giving this feedback, and some of them are really nice about it, right? There was one of our customers, a large insurance company. They had an internal bot, and we were talking about this, and she said, yeah, this bot, we have this bot to find information in our intranet, and every time I talk to it, it's completely useless, but it makes me laugh. So in order for the bot to be successful, it's really key that it solves the problem that it sets out to solve, and that it provides some advantage to the users over existing other options. And I want to give you two examples of bots that I find they really do provide that extra little something, even though they're very simple. So technology-wise, there is nothing to be excited about, and nothing that would get a data scientist out of bed in the morning. But still, it's what needs to be done as a first step in order to reach the cool part. So this is the Starbucks bot, and it's one that is featured in a lot of places as a story of success for bots. And the reason is that it really has some very clear advantages. So first of all, in the morning, I mean, I'm not a Starbucks customer, but apparently there are lots of queues in the morning at Starbucks. So it's a real advantage if you're able to, while you're doing other morning errands, to be able to pre-order your coffee through this bot, and then when you're ready to pass by Starbucks and pick it up, it's already there. You don't have to queue. You don't have to stand in line and waste your time. And the second big advantage is that it's already part of an existing app, which is already successful. So it's meant for loyal customers to allow them to collect points and so on. It already has a user base, so it doesn't mean a huge change for the customers. And then the second one, of course, I have to talk about our bot, which is still in the beta version. It's only available via Apple Business Chat as a first very simple customer-facing release. And it's a combination, like I said, of a clickbot, retrieval, and goal-driven bot, let's say. So basically, you can ask questions. So there is a first level that tries to understand whether the question that you asked corresponds to any of the supported intents, like what can you do? And then we give a list of the supported intents. And then if none of the intents corresponds, then we move to the next level where you simply would retrieve information from an FAQ database. And finally, if also that fails, you have what is called a fallback intent, which says, well, I cannot help you with that, so may I connect you to a live agent or something like that. And it's still, like I said, it's still in the beginning. So I cannot tell you that much about statistics, what requests come in, how successful it is, and so on. But everyone is really excited about it. And I find really the, like I mentioned before, the part that, in my opinion, and why I would personally use it, is not because of Apple Business Chat, but if in the future, as it is planned, it will be available via SMS or via WhatsApp or via other communication applications that I'm already using, I find this really a huge advantage because I don't have to open an extra app or look for the customer support phone number of Swisscom or for my customer ID or username or whatever. I can just start writing and I get an answer and I can be immediately identified with the phone number and so on. So it has some real tested advantages from a usability perspective. So this basically sums it up, and what I want to say as a takeaway for this talk is I think technology is extremely cool, and I loved my time doing research at ETH and other institutions. But I think we really need to give it meaning, and especially from the position of a data scientist, which comes with a lot of expectations of being a magical unicorn and saving the world. We can only do this if we understand what exactly the problem that we need to solve is, and not only what the cool method to solve some problem is. Thank you very much.
Thank you very much. Questions?
Thank you. How much money do you think could be saved if, for example, we would modernize the call centers of, let's say, Vodafone Germany to the maximum achievable level of AI, the way you described it here? How many percent of the support cost do you think could be saved?
Wow, very tough question. Thank you very much. So I don't know about Vodafone Germany, but I can tell you a little bit about the experience of Swisscom. So putting a little bit the chatbot aside, because this was not our starting point, and like I said, not the one where we have the most, let's say, analytics-ready experience. We had a lot of experience with other types of optimizations, like, for example, routing written requests to the competent teams that can solve them. So, and this is not just us, it's also enterprise customers like banks. And there we had a case, for example, where there was a team that was doing this routing manually by just reading requests and assigning it to categories, which correspond to competence teams, and I had an accuracy rate of 60%. Okay, and this team came with a cost, which of course depends on the number of requests that needs to be treated and the location of the team. But basically, by building a system that can do this automatically and within 2 weeks was able to reach 90% accuracy versus the 60% of the human team, you can completely get rid of that team. That's the first cost saving. And then you can also get rid of a lot of ping pong of the different support requests among the different teams, which represents yet another cost saving that is a bit harder to measure, but should still be achievable. So I don't have any numbers for you, but I think percentage-wise there is a lot of potential.
Thank you.
something in the same area. How you think will the bots completely replace the communication with the customer, or if not, how you will model the transition from a bot to a live agent?
Yeah, thank you very much. So, like I already said in the beginning, I am very convinced that human communication is still extremely difficult, even among ourselves humans, and bots are even more impaired than we are in communication. So I really don't see this replacement happening anytime soon. And then about the transition, I think this is already, at least we're aiming towards having it in our own bot. And there are different models. So there is the model where you say, okay, I only have very simple requests in the bot. If they cannot be handled, then I propose a handover to the agent, or even the handover to the agent is a direct option in the bot. There are different models where you have agents that are monitoring ongoing conversations, like maybe one agent can monitoring 5 simultaneous conversations between humans and other bots, and can intervene if something goes wrong. We are also doing a lot of research work around understanding emotions from text, and basically saying if we see that the customer's happiness level, let's say, goes down up to under a certain threshold, then it's time for a human agent to step in. So these are basically the 3 options that I see.
I have a question about personality, because you mentioned that too much personality is sometimes when it doesn't come together with high accuracy, then it's a problem. But still, no personality at all is also sometimes a problem, because if it's nice to talk to a chatbot, then we will go back to it. So, and my question is, how do you find a balance, and also how do you encourage the company to invest in something like personality, because it doesn't, like the link between nice personality that make customers talk to a chatbot doesn't always go directly with sales. So how do you deal with that?
Mm-hmm. Yeah, very interesting question. Thank you. So I'm afraid I'm going to have to disappoint you. I don't think that bot technology is at the level where in the enterprise context you can do something useful with it. So, and I also, when I call a company's support desk, I don't expect the agent on the phone to talk to me about the weather, or that we play a game together or whatever. I just expect my request to be resolved in the shortest time and most efficiently possible. And personality, like you said, is nice, but I think it's very risky because it has to fit the brand of the company. And that's because of the technology limitation, not always necessarily possible, especially if you have very high-end brands where missteps are a catastrophe. That's really just not an option. But I think in cases that are more, let's say, meant for leisure and just casual conversation, there's definitely a lot of value to that. And you see this in different types of bots, but not in others, so it's really not a solved problem. For example, the Google Assistant doesn't have a personality. The most that you can get, like customization from the Google Assistant, is the different voices. I don't know how many, like 5 or 9 or whatever. But they don't necessarily come with a strong personality. It's still just a simple virtual assistant, and from my interactions with the Google Assistant team, this is also the way they want to keep it, because they don't want to personify a machine. Thank you.
Talking about intent classification and entities, So how do you deal with people talking about negation? So saying I don't want something versus I want something. Do you have like different classes for that, or are they the same class and then you describe by entities? And then the other side is we also notice that people write paragraphs as one big message, and then you have to try to figure out what the intent or what the class is. So how do you deal with those cases, or how would you propose dealing with those cases? Yeah.
So we don't deal with those cases because it's not that sophisticated yet. How to deal with them, I don't really have any brilliant ideas for you. I just can tell you, for example, what I know about the sentiment analysis model for the Stanford Sentiment Tree Bank, where negation is handled simply by creating this syntactic tree of the sentence and learning the elements that consist of negation in that way. So maybe this is applicable also for the intent classification case.
Thanks.
But it would be a really, in my opinion, high-cost solution for a relatively small, or I don't know how big it is. I don't know.
Thank you for the nice talk. In terms of the system that you built, how much of this is based on components that you can buy or that you can find somewhere, or how much is built in-house? And is there actually a market for software for software components to build such systems?
Sneaky question. Thanks. So yes, there is definitely a market, and in my capacity as venture associate, I can list you a large number of startups that are in this market. How successful they are, I cannot tell you. There is one very nice framework that we've worked with in the very beginning, and it's a German startup. It's called Rasa.ai, and the reason why they're so cool is that they're open source. They have an open source version, and they also have now an enterprise version. And they're very, I think what I like about them is that they're very open, they're publishing, and they're really in the spirit of the moment. There are also a lot more traditional companies in this market, like, for example, IPsoft, who is claiming to build high-end bots, including avatars and personas and all this stuff, which apparently are highly used in banking. What we have settled on is a company that, or a product that combines the possibility of building rules, but at the same time including machine learning models and combining the two in a, let's say, software architecture approved way. It's a company called Artificial Solutions, what we use at the moment, but also, of course, yeah, it was super important to us to keep the door open for including our own work, because we have a lot of research projects ongoing with the different Swiss universities.
You talked about emotions, right? What about sarcasm or sarcastic comments that users often, especially customers, post? Is there a way to handle them somehow, or? Not that I know.
It's really, I think it's the one, or not the one of the million things that you can use to break a bot. And I mean, not just the bot, any machine in general. I don't think machines are at the point that they can understand or generate sarcasm.
It seems to me that one of the problems faced in creating a convincing conversation is keeping track of the context. So what has been said before in a conversation, how do you deal with that?
There are many different ways. So, for example, what IPsoft does is that they have a knowledge base which they use to identify what exactly represents context in what you've said before. So these include things that you maybe don't even say, but perhaps login information. If you are a logged in user, this is very basic context, right? And then I think they also have a model where they try to kind of create a context which says what is the topic of the conversation and tries to kind of recognize whether you're drifting away from that topic and to keep track like this. But really, I mean, the sustainable and robust way, in my view, should be based on reinforcement learning. And this is not yet there.
Okay, thank you very much. I think we have to wrap up. Thanks for sharing your insights. It was a pleasure to have you. Thank you very much.